Advanced Math Lesson 73, regular polygons, or another way to put it is, cloning isosceles triangles. And the reason why I say that is this example here. So we have got regular polygons. Regular polygon is a polygon that has, all the sides are exactly the same length, all the angles are exactly the same length, and these are examples of that. So like a regular triangle would be an equilateral triangle. A regular quadrilateral would be a square. Regular pentagon, so anything after 4, we just call it by the shape. So this 5-sided figure is just called a regular pentagon. 6-sided figure, regular hexagon, etc. This would be another great time to brush up on your junior high shape skills, because they like to go up to really, really high numbers. So 3 sides triangle, 4 sides quadrilateral, 5 sides pentagon, 6 sides hexagon, 7 sides heptagon or septagon. 7-sided has a P in it. 8 sides octagon, 9 sides nanogon, and then 10 sides decagon. So remember those words. We'll probably talk about them in class. But let's get to the point about isosceles triangles. So let's say that we have a regular pentagon, right? Because this is like the weirder one. And pretty much most of our regular polygon problems will be dealing with 5 sides or more. So this is going to be terrible. Yeah, perfect regular pentagon, right? If we take any regular polygon like they did here, it can be cut into that number of isosceles triangles. So, I'm sorry, not even isosceles, equilateral. Nope, isosceles. Yeah, it's isosceles, because that's definitely not equilateral. Pentagon just seems to appear to be equilateral, and so does septagon. Anyway, isosceles triangle. So, all regular pentagons or regular polygons can be broken up into the same number of isosceles triangle. So hexagon, 6 isosceles triangles, octagon, 8 isosceles triangle. In this case, pentagon, 5. And the cool thing about an isosceles triangle is that we know that these angles are equal. So theta is going to equal to theta. And then we also know that we can cut a vertical line down the middle and turn it into 2 right triangles, or 2 identical right triangles. And the main thing we want to figure out here is the area of one of these triangles. If we can figure out the area of this isosceles triangle, we can multiply that area by 5. We have the area of the pentagon. Or if we can figure out the length of this base of the isosceles triangle, we can multiply that by 5 and find the perimeter of the regular pentagon. And that's the goal here. So, let's see here. The book tells us we have to find the area and perimeter of this regular pentagon that is inscribed in a circle whose radius is 6. Now, that phrase, inscribed in a circle, just means that all the corners of the pentagon touch the outside of the circle. What that tells us is that this length here is going to be 6. So essentially what we're dealing with here, or what we're going to be dealing with, is we have to figure out this isosceles triangle in which both sides are 6. If we can figure out the area and the length of the third side of this isosceles triangle, then we can solve everything else we need to know about the pentagon. Now, the first thing is, how in the world do I figure out an angle? Because like we learned in, was it the last lesson? I can't remember. A couple lessons ago. We need one side and then 2 other parts of a triangle. We've got one side and we've got no other parts. So if we can figure out the length of this angle, then we'll be doing very well. Now, if you remember, angles in a circle are 360 degrees, so one of these is just going to be 360 divided by 5. So if you're feeling super lazy, you can go to your calculator, you can take 360 divided by 5, you're going to get 72. And after you do a lot of these, you'll just start to memorize the central angles of regular polygons. So pentagon, for example, is 72 degrees. So we know that this angle is going to be 72 degrees. Now, we want to take this isosceles triangle, and in order to solve for it, we want to cut it in half like that. So that way we can start using some right triangle trig identities. Now, if we cut this in half, that 72 degree angle gets split into 2 as a 36 degree angle. So now what we have here is we've taken the pentagon, we've turned it into an isosceles triangle, we've taken this isosceles triangle and we've isolated it into a right triangle that looks like this. 6, and that is 32 degrees. Wait, no, not, sorry, 36. So I see 36. Okay, so we've got a hypotenuse of 6, an angle of 36 degrees, and we want to figure out this height, and we also want to figure out this height. Or why did I do that? That should be y, this should be x. Anyways, so we want to use a trig identity when we have the hypotenuse, we know the angle, and we want to figure out the other two sides. So the trig identities we're going to use are sine and cosine. And we should be pretty good at these by now because of rectangular coordinates. So if I take 6 times the sine of 36, that is going to give me the bottom length, or the x. So again, we go back to our calculator, 6 sine 36, closing parenthesis. I get 3.526, which I'm going to round to 3.53. So that equals 3.53. Hey, that's the base of the right triangle. All right, and then I'll take that and I'll multiply that by the height, but I got to figure that out. So that's going to be 6 times cosine of 36 degrees. 6 cosine 36. I get 4.854, which is just 4.85. Now that I have the base and the height, I can figure out the area of this triangle. All I have to do is take 3.53 times 4.85, divide that by 2, I get 8.56. So the area of the triangle is 8.56. So if I want to finish finding the area of the entire pentagon, I remember that this is half of this. So I'm going to take 8.56, multiply that by 2. And I get 17.12, so the area of this was 17.12, and then I remember that there's 5 isosceles triangles, so then I take 17.12, I multiply it by 5, and I get 85.6. 85.6 units squared. So that's the area of the pentagon. Now, they still wanted me to find the perimeter. So if I want to find the perimeter, I go all the way back down to the right triangle. I remember that this base is half of the total base. So I'm going to take 3.53 times that by 2. That gives me 7.06. So the base of the isosceles triangle is 7.06. And then the pentagon has 5 sides. So then I take that base and then multiply it by 5. And I get 35.3. 35.3 units. And that is the perimeter. So that's perimeter, that's area, and we just solved our regular polygon. So remember, the key thing is regular polygons are made up of isosceles triangles. They'll give you the length of the equal sides of the isosceles triangle. You figure out the degrees by taking 360 divided by number of sides. That's how we got 72. And then that'll work on any sided regular polygon you've got. I believe that's all we have for this lesson. Yeah. Cool. Yep, that's it. If you have any questions, let me know on Moodle, and I will see you in class.